Hello, everybody. Thank you for checking out this presentation. My name is Joey Martycz. I'm an affiliate faculty member here at Southwestern College. I teach business quality management and operations management classes. One of the most in-demand or questioned topics within that field tends to be the idea of Lean and Six Sigma. I've had a ton of experience in my past with coworkers, my professional life, students. People in the industry really want to learn about what is Lean and what is Six Sigma. How do these tools help me? How can I use them? And where do I start if this is something I want to learn more about and I want to get experience with? Maybe there's nobody in your workplace isn't really using some of these tools, but you want to implement them. It can be very challenging and very daunting to kind of realize how huge the field is. So the purpose of this presentation is just going to be to break this down a little bit for you, give you a high-level overview of what Lean and Six Sigma is, a little bit of the difference, and kind of give you some foundational knowledge on where to start your journey. By no means will this cover nearly everything you would need to know about these topics. There are entire books and books and books written on them. But my goal is that you'll understand the difference between the two and the similarities between the two. And if you decide to continue your professional journey of learning more about these tools, you'll feel a little more comfortable knowing where you're going with that. So I'll break those down for you here in a little bit. All right. So a couple of things we're going to talk about: high-level historical overview, distinctions between the two. I'm going to break down what is Six Sigma, what is Lean. We'll talk about foundational elements of each, and then I'll talk a little bit about certification because that tends to be one of the most common questions around these tools. So historical overview, I'm not going to read these slides verbatim to you, but they're distinct approaches, but they have a lot of overlap. Many of the tools are used in both schools of thought, so they can blur together a little bit, but that's one common misconception, is that they are different and distinct approaches. We'll cover that here in a little bit. But they both do have their origins in manufacturing. Lean, you could go back further than Henry Ford, but kind of the most recent modern implementation of Lean is Henry Ford in the assembly line and his goal to eliminate waste from those processes. Six Sigma originated at Motorola and again built on the shoulders of previous companies and previous processes. But Six Sigma, as it's currently known, started at Motorola and was kind of expanded and made popular by GE's CEO, Jack Welch. So the high-level basic distinction between Lean and Six Sigma, what we're really looking at here, it comes down to the primary goal. Primary goal of Lean is to eliminate waste, and that is anything that doesn't add value to the process as defined by the customer. We'll cover that a little bit here in a second. Primary goal of Six Sigma is to eliminate defects. That's generally a quality defect or anything that's non-conforming, again, to the demands of the customer. But those are two different, although sometimes interrelated, goals. You could have a lot of waste in your process and still have a process that's defect-free, if that makes sense. So you could be Six Sigma quality, but have a lot of waste in your process. Now, what you'll see as you get on that journey is it's not likely for that to happen. As you improve one, you kind of improve the other, sort of as a matter of course, but that's not always the case. And then the central methodology used within the two. And I would say that Six Sigma is much more adherent and it's much more reliant. You must use this process here called DMAIC, D-M-A-I-C, and we'll cover what that means here in a minute. But DMAIC is the complete backbone of Six Sigma. Without DMAIC, you do not have Six Sigma. PDCA is less structured and less formal, although it is still a process that's followed, and that stands for Plan, Do, Check, Act. And the idea there is that you're going through what the Japanese call Kaizen, and that is a Japanese word that means continuous improvement, constant improvement. So Lean is not the kind of thing where you say, okay, we've gotten lean enough, I've eliminated enough waste from my process, I'm good. You know, you're never done improving, you're never done eliminating waste and optimizing your process. Right, so what is Six Sigma? Like I said, it's broken down and its foundation rests on the concept of DMAIC, which is, we'll cover that, but it's define, measure, analyze, improve, control. Six Sigma actually reflects the mathematical root of the Greek letter sigma, which has to do with how many standard deviations beyond the mean the number of defects are. So in a normally distributed curve of defects, your sixth standard deviation would put you at something like 99.999997 percentile, right? So effectively what it means, and what you'll learn in Six Sigma as you get into the black belt level, can get very heavily into statistics. For those of you that maybe aren't as familiar with that, or, you know, it's been a while since you've taken a college stats class, what you just need to understand is that it represents it's very improbable that you'll have defects when they're that far away from the mean. When your average performance is that good, the number of occurrences of defects is very, very low. So low, in fact, that it ends up being measured in terms of number of defects per million opportunities. And on a curve, when you break it down mathematically, Six Sigma would actually equal 3.4 defects per million opportunities. So that, you know, if you're making a million cars, 3.4, or, you know, round up to 4 of them would have any defects at all. And there's a lot more math that can go into that, but that's the high level view. And one thing to always keep in mind here is that defect is always defined by the voice of the customer. So the manufacturer, the company, whoever owns the process doesn't get to decide what a defect is. It has to be based on what do the customers actually want. And there's a whole methodology of how you capture that voice of the customer. It's a little beyond the scope of this presentation, but just wanted to make sure you're aware of that. So DMAIC, again, at a very high level, this is a book worth of information that we could go into, you know, countless levels of detail. But at a high level, it's define, measure, analyze, improve, and control. And you're going to do these in order. So what you'll see a lot in, especially, you know, kind of counterintuitively with people that have very foundational knowledge of Lean and Six Sigma, is they want to jump right into improve. They think that they see a problem and they've got an idea. They just want to implement some cool new process and make it really flashy and cool. And a lot of times that fails. And the reason that fails is because we didn't do the first 3 steps before that. So you have to really understand your problem. You have to understand all of the inputs to that problem. Who are the suppliers? Who are the inputs? Or what are the inputs? Who are the customers? All of that whole chain, you have to really understand it at a very good level before you can start improving. And then again, once you really understand your problem, how are you going to measure it? What will success look like? And what quantifiable level of improvement will you see along that problem? Then it's your analyze. And again, it's really, there's a ton of information here, but it's brainstorming to see how do you truly eliminate that root cause? What is the single most important action for you to take to change it? Then you see improve, and that's where the question starts to become, how can I make this change? How can I implement it? And again, you can't be afraid to test and iterate and use a new solution if it doesn't work. Finally, you have control, and that's how you're going to stabilize and maintain the countermeasures put in place. So some of the tools that you guys will see within Six Sigma, and by no means is this an all-encompassing list, but things that can be used for root cause or measuring in that stage of the process would be 5Y, quality function deployment. It's oftentimes called the house of quality. If you see that in the future, that's kind of where this falls. Pareto analysis, or an 80-20 rule, if you guys have heard of that, and a fishbone diagram, which is another brainstorming tool. There's also statistical tools, and there's a lot of different stats that can go into this, but things like a regression analysis or a little more simple scatter diagram to help you identify truly quantifiable deviation from the mean. And then some other tools such as value stream mapping, which you'll also see in the Lean section, critical to quality tree, which is one of those tools used to help identify the voice of the customer, and then a control chart or a run chart, which is just a chart to keep track of how often a certain thing happens or a certain series of things happen. So these range anywhere from highly advanced computer-driven, very software-reliant statistical analysis to pencil and paper, checkbox every time that this piece of machinery doesn't work. It's not about necessarily the flashiest or the coolest data collection method. It's about what really highlights and illuminates the true problem and helps you understand what you need to solve it. So don't get too wrapped up in the tools themselves. Focus on understanding the real root cause and finding a good solution that you can implement to solve it. Okay, so breaking down lean, like we said a couple slides ago, the main goal of lean is to eliminate all waste from a process through that iterative continuous improvement, again called Kaizen. Waste is anything that doesn't add value, and then that's, again, from the voice of the customer. That's a really common overlap between these two. You have to understand that as a customer, there are a ton of things that, even if they're business essential, you can't do the process without them. They don't necessarily add value from my perspective. All right, so a really common example would be if I want to purchase a car and you make a car in Ohio and I live in Arizona, you physically can't get the car from Ohio to Arizona without transporting it. There's going to be some cost built into into that car because of that transportation. It's kind of unavoidable, but that doesn't mean I accept that as a base on I have to pay that value. I would prefer as a customer that it's built here in Arizona and I don't have to pay that extra transportation cost. So when we talk about waste, it's not always something that you can 100% eliminate, and sometimes there are things that you have to do as part of doing business. Another good example would be every car company has to have a human resources department. They have to have accounting. They have to have a lot of support functions within their company that don't necessarily make my experience owning the car any better, right? Like for me, as I drive the car, the fact that Honda, Toyota, whoever made the car, doesn't have has a HR staff doesn't improve the experience I have driving the car, but it's essential for the company. Those are still non-value added, but they are essential. So understanding that sometimes when we say waste, it's more effective to say non-value added, because you can't always eliminate things, but you need to understand they are not improving the customer experience. So the central methodology of lean, like I said, is PDCA, or Plan, Do, Check, Act. That's made famous by one of the main thought leaders in this field. His name is W. Edward Deming. A lot of cool information. If you guys go down this path of learning more about Lean and Six Sigma, you'll definitely learn more about Dr. Deming. But the idea basically is that, again, you work in sequence, you plan your solution, you check to verify that you got the correct response you expected, that you did see the improvement you thought you would, and then you act. And you continue on that cycle forever. It's never ending. You're never lean enough. You're never done optimizing. So when we look at waste, there are essentially 8 wastes, and this is probably the central tool of lean. If you're interested in learning about lean, learn PDCA and learn the 8 wastes, and you'll have a very good foundational level of information. But the 8 wastes that are commonly seen would be defects, obviously because of the rework that it causes, overproduction. So this is making more than is needed at the time that the customer needs it, right? So you see this a ton of times. An auto manufacturer, again, could make 200,000 cars. If the demand is only 100,000, now they have to spend a lot of time and money figuring out what to do with those extra cars, how to transport them around, how to move them, where to store them. Producing more than is needed causes a lot of problems, in addition to the fact that you have potentially sunk labor costs into that process, into making those cars that may never get sold. So you've invested the labor and the resources, but you're not going to get the return on your investment. Waiting, again, wasted time of workers. So similar concept to the overproduction there, but any labor that isn't working towards creating value, you can't go back in time and recapture that time. Time is linear, and once you've spent it, it's gone. Now, the key distinction there that some people will forget is they think that means your employees should never be, quote unquote, standing still. It doesn't necessarily mean it. Your goal should be to make sure that your employees are always doing something that creates value for the customer without overproduction. So you have to watch those two. They're closely related. You can't say, I'm going to avoid waiting and I'm going to make more than I need. The correct solution there would be to make sure your staffing level matches the work. Non-utilized talent, and this is kind of having people work below their pay grade. And this doesn't mean that some people are too good or anything like that. It's not about kind of class separation in the workplace or anything like that. But what it really comes down to is using the skills that are needed where they're most needed and looking out for those hard to find or in-demand skills that you have a limited access to. So if you have 2 engineers that cover your entire factory, you don't need them jumping in on the line and repairing most machinery. You have mechanics that can do that. You have engineers that have very limited time, and you need to make sure you're applying them to the right problems. Similar thing would be teaching some of your people on the production line to improve or to fix something that's a very common, hey, when this circuit breaker trips, you can do these 3 steps to return your system to operation. You don't necessarily need to call a mechanic out every time that happens. Those are good examples of not utilizing your talent correctly. Transportation, this is pretty simple, moving things unnecessarily. Like it says there, it can be either macro or micro. So this could be that earlier example I gave, moving something from one side of the country to the other, when perhaps it would make more sense to put another warehouse or another facility to create that product on each side of the country, so you're minimizing your transportation. Or it could be micro, which could be within your facility. Hey, we have this warehouse and we keep all of our supplies on one end of it, but we use them at the other end. So every time we need to refill this tape dispenser, we have to go all the way to one end of the warehouse and carry this stuff back. Move your things to the point of use. That includes supplies, parts, people, whatever it is. Inventory, again, big opportunity for waste within a lot of organizations because it ties up your resources. So inventory could be millions and millions of dollars that you can't spend that you could have otherwise spent if you weren't carrying all this extra products. There's also the risks of, the market changes. If it's perishable product, it could expire while you're holding it and then you've lost that money. Or the market could change, that product could go out of favor while you're holding it, and now you're stuck with a bunch of T-shirts or whatever it is that you can't sell, that people don't want. So keeping inventory that matches customer demand, again, the voice of the customer, is going to be essential here. Motion, similar to transportation waste, but this is unnecessary movement by people. So if every time I need to get a specific tool that I use 30 times a day, if I have to take 10 steps every time, it would make a lot more sense to put that tool directly next to me, put it right there at the point of use. And then excess processing. So we talk about the voice of the customer again. You can over exceed what the customer wants. And that can be in a number of ways. So if I'm buying a book, my main requirement, depending on my, if I'm a collector or something, that's different. But if I'm a student and I'm wanting to learn something, my main goal is to digest the information from the book. So there are things that you could do that maybe aren't essential. You could make the quality of the book too high. You could make the binding too strong. And it sounds counterintuitive, but if that process costs an extra $5, injects $5 of cost into the book, perhaps I'm okay with a slightly thinner cover at the expense of, lowering the cost by $5. So again, that's where understanding the voice of the customer is critical to doing this. You have to know exactly what the customer wants before you get your processing in sync, and don't over or under process to take care of the requirements of the customer. A couple examples of some lean tools that you might see pretty commonly, and again, this is nowhere near an exhaustive list, but you'll see some stuff like 5S. If you've heard of that, or if you haven't, you will very much see a lot about 5S when you get into this world. That stands for sort, set, shine, standardize, and sustain. There's a couple different versions out there. Some places will call it 6S with the inclusion of safety. That's not to say that if a company says 5S, they don't care about safety. The idea is that if you do these 5, safety should be inherent. That's kind of the difference there. But the goal in either case is to make defects and waste readily visible. Again, that's where it's perfectly aligned with both success and lean, because it'll help improve visibility to problems. So you also have Kanban, which is a Japanese word that means flag or signal. The idea is that you can immediately, quickly communicate a problem or need. Standard work, which is identifying the best processes and then standardizing it, with the caveat there of PDCA. So once you identify the best process and you standardize and you have all of your people in a certain process doing things the same way, you continue to iterate and evaluate on, is this process still ideal? Can I optimize it? Can I remove waste? Can I improve it? You're continuously going through that circle. Value stream mapping, and which is another idea that we'll cover here in a second, and a Gemba walk, or go to Gemba, which basically the idea is be out where the work is done. Gemba is a Japanese word that actually translates to where the work is accomplished. So the idea being that you can't solve things, you can't improve a process by sitting in the middle of a conference room. You have to really be out there where the work's being done, watching the process with your eyes, doing it yourself, talking to the employees that are carrying out the process to truly understand it. Just some visual examples. So over here, you can see an actual value stream map. So the idea of how this would work would be you would break down all of your processes, and I'm not going to go into all of the details, but you can see that we have SIPOC broken down here. And what you're really looking to do is identify time. So you can see this lead time ladder will tell you your total production time. So what you're looking to figure out is, how do I optimize either this waiting time between processes or the process itself to streamline in a way that lowers overall lead times. Not a tool that applies to every single situation, but that's something you guys will definitely learn about if you continue through this journey. And then for Kanban, this is called an and-on light. And what would effectively happen is you would have different meanings for different colors. So, maybe if I'm using just this red, yellow, green one here, green means I'm totally optimal. Yellow is I'm below 50% on a certain part and I need to be replenished. And red could be a mechanical work stoppage. And, each organization and process will design their own setup for what these different colors look like. But and-on lights is something that you'll see really commonly in this world. All right, so certifications. Before I go into this, I just want to highlight, again, there is no central governing body of certification for Lean or Six Sigma. So you will see, especially people that come from the project management world, there is one for sure source of truth. PMP is for sure the certifying body for project management knowledge. It's sort of the industry standard. We don't have that in Lean and Six Sigma. So what you will see is several corporations and universities offering their own certifications. Some are better than others. They're usually tied to belts. I've seen everything ranging from what you see here: white, yellow, green, black belt, master black belt. More traditionally, you'd only see green, black, and maybe master black belt, but they're starting to offer, certain groups are offering white and yellow belts. And the one thing I want to call out here is certification doesn't necessarily make you an expert, and the lack of certification doesn't necessarily mean you don't know what you're doing with this. Me personally, I would much rather take somebody who understands these tools really well and knows how to implement them, but doesn't have a belt, over somebody who is certified but has never really used the tools. So don't get too hung up. This is my personal advice, but don't get too hung up on certifications. But they can be very beneficial to back up the knowledge once you've obtained it. And then many employers will provide their own tests, especially if you're applying for a job where your primary function will be as a process improvement or a Six Sigma specialist. A lot of organizations will provide their own tests to validate and verify that you have the knowledge that you're claiming to have. So it's not the kind of thing that you can take the test one time, oh, I got my belt, I'm never going to use these again, and I'm done. If you want to go down this journey, it's sort of a lifelong journey that you're going on. But if you are pursuing certification, the best options usually include either rigorous academic work through lecture or class project. A lot of the good ones here, sometimes they'll pair them with work experience where you have to do something at work, bring it in, talk about it in class, go back to work. So you're kind of working a project and you're doing it real time, and you're getting the academic side to highlight the learning there. And another thing is the proctored independent closed book exam. So there are some organizations that book the test is a little more open book, or you don't maybe even need to take an exam, but the academic portion isn't very rigorous. This is sort of like anything else in life. You're going to get in what you put out. If it feels really easy to get your certification, maybe it was too easy. But some examples that do some of this different training and some of these things. American Society for Quality, or ASQ, is one of the more popular certification bodies. Again, there is no single governing body, but ASQ certainly issues a large number of certificates, and generally their certifications are considered very relevant. They're thought well of within many industries. And then International Association for Six Sigma Certification, sort of the same thing. They do an independent exam. They don't offer any training, so their goal is not to sell you training or sell you support. They strictly are issuing an exam to verify your knowledge. And then many companies or universities offer their own variety of certificates. And that can range from very, very incredible world-class training to, middle of the road or maybe not so good. So you kind of have to keep your wits about you and look for some of these things as you're getting certification. Cool. So that is it for the initial introduction to Lean and Six Sigma. Quick conclusion for you guys, or summary. So Six Sigma, remember, uses DMAIC, and the goal is 3.4 defects per million opportunities. Lean focuses on Kaizen, or continuous improvement, by generating value through eliminating waste. So again, the difference between Six Sigma and Lean: Six Sigma is defects, Lean is waste. Many of the tools are common between both. You can be Lean or Six Sigma or both. And there's no single certifying body. Again, my advice to you guys: proficiency in this is a combination of education, experience, and certification. You want to work on growing all three of those continuously. Again, if you're going to adopt this mindset, Kaizen within your own learning, you should be growing across all three of those categories continuously. So that'll do it for this. I hope you guys have enjoyed this. Please, there's a ton of information on the internet. Research through this. If you're a business quality or an operations management student, most of your textbooks will have some information about Six Sigma. Start to explore this. This is a set of tools that can provide enormous evidence for your professional life. So I hope you've enjoyed it, and have a good day.